Now it's time to fill in the table. Remember, each row is the transform from link I-1 to link I. If your DH parameters are correct, then a basis vector of link I-1 should be coincident with the corresponding basis vector in link I after the homogeneous transform is applied. For example, x0 should map to x1 and z0 should map to z1. For I equals 1, we are considering the transform between frames 0 and 1. Alpha 0 is the twist angle between z0 and z1, measured about x0 in a right-hand sense. A0 is the distance from z0 to z1, measured along x0. Well, z0 and z1 are collinear, which is very convenient because for collinear axes, alpha and A are always 0. The link offset, d1, is the sign distance from x0 to x1, measured along z1. Again, we have collinear axes, which makes d1 0. Joint 1 is a revolute, so theta 1 is the only non-constant term in row 1. It measures the angle between x0 and x1 about the z1 axis in a right-hand sense. Since x0 and x1 are parallel when theta 1 equals 0, this term is just theta 1. Here's an important point. You may run into cases where the two x-axes are not parallel when theta is 0. If so, the theta term would be theta plus whatever the non-zero but constant offset happens to be. So be aware of that. Let's move on to I equals 2. That is, the transform between frames 1 and 2. Z1 is parallel to Z2. So alpha 1 is again 0. A1 is the distance from Z1 to Z2 measured along x1. Here's A1. To find the actual numerical value for A1, you would have to consult the manufacturer's specs or appropriate joint origin tag in the manipulator's URDF file. D2 is the sign distance from x1 to x2 measured along Z2. Since x1 is collinear to x2, D2 is 0. Joint 2 is another revolute, and in fact, the same logic applies as you saw in joint 1. Therefore, theta 2 is just theta 2. On to row 3. Z2 is parallel to Z3. This makes the twist angle, alpha 2, equal to 0. A2 is the distance between Z2 and Z3, measured along x2. D3 is the sign distance from x2 to x3, measured along Z3. Notice that to get from x2 to x3, you have to move in the negative Z3 direction. Joint 3 is prismatic, which means D3 is the only variable in row 3, and thus theta 3 is 0. Finally, row 4. This is similar to the transform between links 0 and 1, because I again define frame 4 to be coincident with frame 3 when theta 4 equals 0. As a result, alpha 3, A3, and D4 are all 0, and theta 4 is just theta 4. Congratulations! You made it through a very long and difficult concept. Now go outside and stretch your legs. You definitely deserve a break.